Okay, this is the video tutorial for pages 6 and 7 in your Unit 2 homework packet. Let's get started. Your answers are here. Okay, hopefully you know this by now. But remember, we've got our symbol. The small number is our atomic number, which is protons. The top number is the isotope mass number. So that's total protons plus neutrons. So looking here, S is sulfur. S-U-L-F-U-R, sulfur. The mass, I just copy the number that they give me on the top for the mass, 32. Protons is the smaller number, 16. So neutrons is ape man. Mass minus atomic equals neutrons. Okay? There are questions like this on your Unit 1 exam as well. So 32 minus 16 would be 16 in this case. TH is thorium. T-H-O-R-I-U-M. I think I spelled that right. Or is it thallium? Hang on, I'm going to grab my periodic table out. It's not even on that one. I'm pretty sure I'm right, but now I'm all embarrassed. TH, let's see if we can find it. TL is thallium. So yes, we're good. It's thorium. Like I said, it's thorium. It's fine. We're great. Mass number is 230. Protons would be 90. So the big one minus the little one is 140. But I have been known to do this wrong on videos before. So 230, top number, minus the bottom number, 140. Yeah, like I said, 140. We're okay here. Those top 4 questions are the opposite of 5 and 6. So on the top questions, we gave you the symbol, you gave me the numbers. Now I'm giving you the numbers, you need to put them back into the symbol. So it says, write the isotopic notation for an atom with 82 protons and 103 neutrons. So the first thing you have to know is 82 protons is your atomic number. And number 82 is lead, Pb, plumbium in Latin. That's why it's lead P. It just is. It's weird, people. Pb is number 82 on the periodic table. That's how I chose my symbol. And then my bottom number, which it says up here as well, is protons. So 82. And the top number is my mass. And mass is the total of protons plus neutrons. So we just add those guys together. Okay. We're going to say 82 plus 103 is 185. That's my total mass for this lead. Now, on our periodic table, it tells me the average lead is 207.2. So this is definitely too little to exist to be radioactive. It's really, really little. This is a vocab question right off of your notes in the vocabulary section in your notes. It says an isotope with an unstable nucleus is called a radioisotope, is kind of what we're going for. Radioisotope. You could also just say radioactive. Okay, but I'm going to write radioisotope. Okay. And it's your number of neutrons that makes you radioactive or not. It makes you stable or not stable, depending on how many protons and neutrons you have. Which is right here, right? Our stability worksheet. This N equals Z line you can ignore. That's just telling you if your protons and neutrons are equal. So really what we're showing you is small atoms tend to be stable when protons are equal to neutrons. But the bigger your atom gets, the more neutrons you need. Okay, so it doesn't stay a 1-to-1 ratio. So my dark color is going to be stable. The lighter color means unstable, which is radioactive isotope. Number 3, an isotope of calcium has blank protons and 21 neutrons. Okay, well if it's calcium, it can only be calcium if it has 20 protons. So that's the answer here. First answer. And then it asks me, is it going to be stable or radioactive? Well, we need to graph those. So 20 protons. My protons are here on my y-axis. 20 protons is there, and 21 neutrons is here. And that falls right in that darker, stable color. So that looks like it would be a stable isotope of calcium. And then it tells me to write the notation for that one, just like we did on the back for number 6. Okay? The symbol for calcium is big C, little a. The bottom number is protons, which we said for calcium has to be 20. And the top number would be the mass of this isotope. So these protons plus these neutrons would be 41. Let's look at 6. An atom of the isotope 23994 Pu, which is plutonium, dun dun dun, is likely to have 145 neutrons and be stable, 145 be radioactive, 94 unstable, 94 and radioactive. Okay, so we're going to take out some garbage, but first we need to solve for neutrons. So I'm going to say mass minus atomic is my neutrons, which, let's see if I can get out glare, 239 minus 94. 145 neutrons. So that makes C and D garbage. Has to be 145 neutrons. So let's graph that. 94 is my protons, 145 is my neutrons. So 94 for protons, that's 90. 94 is going to be just under halfway. Okay, I don't have to graph anymore. Look at that. If you have 94 protons, there is nothing that can be stable about you. There's nothing. If we're going to graph 142, it's like right here. There's no stable options. Once your nucleus gets above about 75, 80 protons big, it can't be stable. Okay. So I would say, yes, it's 145 neutrons, but no, it's not stable. 145 neutrons and radioactive. That's our answer right there. And that's going to answer number 8 as well. The element americium, America, has 95 protons. Could stable isotopes exist? Well, 95 protons, that's just a little bit bigger than plutonium. No. So I'm not going to say yes. I'm going to say no. That nucleus would be too big. Okay? There's no way for it to be stable. That's today's homework. Great job.